video, we're going to recap what we've done with completing the square and learn a new topic to do with quadratics. Now, one of the key things we've been learning for the past 3 or 4 lessons is how to complete the square. So let's have a look at this function on the left-hand side. You can see this is in completed the square format because we have x with a number in a bracket squared and then another number on the outside. We know that the vertex is whatever this number is, but we change the sign for the x value. So the x value is positive 2. And the y value is always this number, which is negative 9. Now, the completing the square format helps you find the vertex of the quadratic. Then another thing we learned how to do was how to rearrange this equation to find the x-intercepts. Now, the x-intercepts are also called zeros. So what we did is we started rearranging the equation. So, for example, we moved the minus 9 onto the other side of the equation, or we added 9 to both sides, so x minus 2 squared is 9. And then if you were to solve that, we are going to have the square root of 9, which is positive 3 or negative 3. And then obviously to find the final answer, we have to add 2 to both positive 3. So that would be 5. And we'd have to add 2 to negative 3, which would be minus 1, which is why when you solve this completed the square format, you get 5 and minus 1, which is exactly where it crosses the x-axis. This is what you should have known up until now. Now, what we're going to go over today is slightly different, but not too complicated, and it involves equations and quadratic graphs. So, we are going to be specifically looking at the following question. Find the equation of the quadratic given we have 2 points, 1, 3 and 2, 8. So what we have to do for this particular question is substitute the equation. Substitute 1, 3 into the equation. So I'm going to use a text box and you're going to fill this out on your worksheet. So first of all, we substitute in y, which is 3, into the equation, and x, which is 1. And then we simplify the equation. 3 equals 1 lot of a plus c. And you can see that because 1 times 1 is 1. So we have 3 equals 1 lot of a plus c, which obviously simplifies to a plus c. Then we substitute the other point into the other equation. So we have the 2 as the x, the 8 as the y, 2 squared is 4. Now we have 2 equations which we can simultaneously solve. The reason why is because they both have 2 unknown variables, a and c. So we want to decide and think about how we are going to eliminate one of the variables. So we have the a's, 4a and 1a, and the c's, 1c and 1c. So what we're going to do is we're going to subtract the bottom equation and we're going to take the bottom equation and subtract the top equation. So we're going to do 8 minus 3, which is 5, 4a minus a, which is 3a, and c minus c, which is 0. There's some slightly different working out on the screen. And we obviously know that 4a minus 1a is simply going to be 3a. So this equation is a little bit strange because we're not getting whole number answers, but that's okay. So we are going to have 5 equals 3a. Once we've done that, we are then going to decide that a is 5 divided by 3. Obviously, if you're typing this in an investigation, please use the division symbol or fraction button. This is just a quicker way to show you. We're then going to work out what c is. So all you have to do is you choose one of the equations. We're going to choose the top equation, 3 equals a plus c. We're going to substitute in our value of a, like we've done with simultaneous equations before. So 3 equals 5/3 plus c. So clearly c is going to equal 3 minus 5/3. Now you have to think a bit more carefully what that means. 3 is 9/3, so we're going to do 9 minus 5/3, which is 4/3. So simply c is 4/3. So we take this and we type in 4/3, and then we've obviously got that our a is 5/3. What we're going to do then is we've got y equals 5/3 x squared plus 4/3. And we're going to double check it's right. So our coordinates are 1, 3, 2, 8. So we're going to go back to Desmos, remembering 5/3 and 4/3. We are going to clear all of this. Y equals 5/3 x squared plus 4/3. And we're going to cross our fingers this is correct. So the first thing we're going to check out is 1, 3, and we've got that coordinate. And then the next thing we're going to check out is 2, 8. So in the exam, you might just be given the two coordinates, 1, 3 and 4, 8, and you might be then asked, given the coordinates 1, 3 and 4, 8, find the equation of this quadratic, and that is what you would do. You would solve it in this way. This quadratic is quite simplistic because it crosses c when c is 0. This is why there is not a third term in the quadratic. One final thing I'd like to go over, which is not really that essential to this course but might be important for M5, is what we did during the lesson last week, and that is the transformations of different types of quadratics. So, for example, we talked about moving or transforming graphs left and right, up and down. So we said if we're moving a graph up and down, it's really obvious because whatever this number is, it will move up that many spaces. So let's say we change this to C and we make it into a slider. If we make this positive, it just moves up higher and higher, the bigger the number becomes. And if it's negative, the graph moves down lower and lower. Whereas if we are manipulating the number inside of the brackets, let's call this C, let's call it plus C, and we're going to add a slider this time. You can see it's counterintuitive. What do I mean? So let's start at the number 0. If we start at 0 and we're going to move the slider, if we move to the right, the graph actually moves to the left. And if we move to the left, the graph moves to the right. So if C is negative, the graph is transformed to the right. And if C is positive, the graph is moved to the left. So I hope you found that helpful, and I hope this has recorded well.